All right, well, thank you everybody for joining the Cool K-PAC Competition session. We started this competition a few years ago. What we're going to do today is I'll give you a little bit of a background on what the competition is. We'll talk about how it works. This is our 4th annual Cool K-PAC competition, so we're excited. This is one of our favorite parts of the conference itself. But from a background perspective, a lot of times when we've been going through different interactions with customers, we've been going through different interactions with organizations, whether it's at the conference or just in general practices, we get a lot of questions about, how do other people use the software? What are the things that people do? What are the best practices for implementing it? And we came up with an idea a few years ago to start holding this competition. We weren't quite sure if it would work out, if it would be something that people appreciated. But what we found as we've gone through it is it's really one of the most popular sessions within the conference itself. And we're happy to do it now, like I said, for the 4th year in a row. Go through just an overview of how it works. Leading up to the conference, we start soliciting different knowledge packets to enter into the Cool K-PAC competition. There's really no definition for what makes a K-PAC cool. So we take different entries, and then as the conference gets closer, we choose 3 finalists. Those finalists will present their knowledge packets to us here today. And then once we get done with the 3rd presentation, we'll open up the polling. So on the right side of your screen where you were answering the polling questions, we'll have a poll go live once we're done. And at that point in time, you'll start to vote in the poll, and whoever receives the most votes will win the competition. Over my shoulder, you can see the Cool K-PAC Cup, which is the trophy that gets presented to the winner. So with that being said, I think we're going to get things started. Our first participant is Mauro Marconcin from ZFTRW, and he will be taking us through his K-PAC on Shim retention design rules.
Thank you, Josh. Greetings, everyone. And my name is Mauro Marconcin. I work for ZF, and I'm wearing my Oros shirt with the hopes that it can give me more votes this morning. So this is the problem we set out to solve. We have this part, the brake pad, and there's an endurance test that you have this shim insulator over that sometimes we present failures. So we saw an opportunity to make our design guidelines better. Currently, we have a simple rule to create this part, design this part. And we would like to have more logic into it. So we want to recommend the number of retention posts. We have circular posts, and we also want to recommend the diameter of those posts once the adhesive between the parts failed. So you can go to the next slide, Josh, please. So we wanted to map out the main design flow. In the beginning, we collect the main inputs for this calculation. So we wanted to guide our engineers. Maybe somebody can mute their line, please. There's quite a bit of noise in there. Maybe it's Jim. Josh, do you have the presentation back? Okay, so let's go through it. This is the main design flow. We want to suggest engineers in a standard form. And so this is the first gate we have. You guys are gonna see when present the K-PAC. But even for some reason, the design engineer cannot use the standard form, there's a second gate which checks the stress level on that part. And if it's okay, the process is finished. If not, it still suggests some modifications in some of the design variables, number of posts, post diameter, gap between post and hole, till you achieve an acceptable stress level. And once that is achieved, we can finish the process. So you can go to the next slide, Josh, please. I'm going to go really quick on this slide. So this is an example of us modeling the physics for this interface. We put the forces involved on this. So we are interested on this green part. That's the part that presents the failure, and we want to control this force on this interface. And you can go to the next slide, Josh, please. Also, this is a very busy slide, but just gives you an idea about the complexity of this calculation. Well, we went to a textbook to find out how to calculate the stress level for this type of component or this type of geometry, and we have listed on the green box all the variables that go into it. So this is just a very high level and how we created the design rule. Next one, please. Once we had the design rule, we decided to do not the AI as Jeff was presenting yesterday, more I guess, NI, natural intelligence. So we went through all the designs that we have and we applied a design rule virtually, and we wanted to understand what would be the stress level if we had applied a design rule for the successful design. So this allowed us to calibrate the design rule, making sure it works for most of the cases. And as I said, even if it doesn't work, let's say the force level at that component is higher than predicted, you still have a chance to catch it because it calculates the limit, the stress level that you're up to. You can go to the next, Josh. I think at this point we will take a look at the K-PAC itself. So in this case, I mean, you can glance a little bit, Josh, if you go maybe roll down a little bit. I just want to show a couple of aspects of this K-PAC because we want it to be a useful tool for the engineers. There's some steps in how to apply this. The K-PAC actually has instructions in how to run the design table. If you click on the lightning for the design table, I want to show you how to works real quick. So this is a really two-step process. If you pick, for instance, piston number, Josh, right in the middle, and click 1 perhaps, and if you go to piston diameter or piston size, caliper piston size right above, you can pick any point, any of those numbers, and you click resolve or evaluate. So this is going to give you the recommended number of posts and number of the diameter of the post that the user has to go through. I'm not going to go through the rest here. So with this number, which is some numbers that I just modified for this presentation, the user is supposed to go back into the top of the value table, put those numbers in, put the rest of the information, force level, other attributes, and it's going to calculate the stress level for this component. If the stress level is okay, it's going to show as green. If not, it's going to show as red and recommended modifications to the inputs to go through. So I believe that's what I had, Josh. Thanks, everyone. And I dedicate this K-PAC to Jeff Mayhew's dog, Zoe. Thank you.
Okay, I think it's my turn. Good morning, everyone. I'll share my screen. So we had a situation where we had several seals that we wanted to put in panels that had holes in it, either a plug or a tape. We had a extremely large list of information, and our first go around, we came up with putting it all into a value table. And so we filled out the table and we put all the information in, and then we can come in here to the lookup table and select the items that we want, hit resolve, and it'll give us the output. There was some issues that we had with this because there's instances where I can pick a combination and not get anything. So we decided to go back to the drawing board, and instead of having each of these in a single table, we did something different and made each of them a separate K-PAC. And now I can do the same thing, come in here to filter, and I can go to dynamic. And now I can say I want a round hole that's one of these two sizes. I can choose the primary usage, search and build grid, and it returns the item that I want. There was another benefit to that. I can also filter through here and just say I want 10.1 hole. And then it shows me all of the 10.1 holes that I have to choose from. I know they're all the 10.1 plugs that I have to choose from. It tells me what the plug seal type is. It tells me what the primary usage, secondary usage. And then the other thing that we didn't have using a value table was we associated the hole with the plug. And so now you can see the actual whole K-PAC that we have. The nice thing about this is I can go into this K-PAC, go to relations, say K-PAC, and I can track to see what plugs are calling out for which holes. We needed to do something like that because we had a proliferation of non-DFM compliant holes. And as a designer, they're just going to use what the best practice calls out for. And this allowed us to see which best practices and what usages were calling out for those non-compliant holes. And then we can talk to the BFO and see if they can use a different size hole or if we needed to add that hole to the DFM list. And one final thing that it would allow me to do, if I go in here and I'm going to turn dynamic off and turn it on to static. I'm going to pick tape. And I know I have a hole that's, say, 25 millimeters. And if I go into here, there isn't one. But I can go here and I can pick a tape. This works for 20, 30, 35, and 40. And I know that this plug right here will satisfy my need, that this tape will satisfy my need for that particular hole size. So it allows me to access the information in numerous different ways. And then if I take this and add it to the assessment, I can then go back and check against it within the assessment. And that's it.
All right, thank you, Darryl. Appreciate you walking us through that knowledge packet. Our next presenter is going to be Jim Carter from MIT Lincoln Laboratory. Jim, let me share my screen.
Okay.
Walk through your knowledge packet.
So as Josh gets that up, one of the things that, because we are an R&D operation, we tend to work with a lot of different things at different times. And from a design perspective and working with SolidWorks, there are aspects of SolidWorks that allow us to maintain essentially two databases, which is not always the most convenient way to do things. But we do work within a connector to SolidWorks to kind of streamline these processes. And one of the things that we looked at before you start the video here, we can talk real quick about the K-PAC that we're gonna have up. What we're looking at is material, and there are material databases that we have, locally within the SolidWorks structure, and we also want to be able to check drawings and check models against those against those material information. So we developed first a material K-PAC, which became a little cumbersome because of the amount of materials and the types of materials that we use. We then changed that so that we actually have a single material K-PAC for each material, which we have tied to different finishes and other things that we want to check from a drawing perspective. And so it is essentially, it's a value table. Josh, if you scroll down just a little bit, where we have a material type. In this case, this is just the A36 steel material, different finish types, things that are approved or things that are not approved, for use, generically, so that you cannot match a material up to a finish that is not to be used. The blue is kind of a catch-all for us, that if you have two things that don't match, if you're going to try something new, if it's something that hasn't been done yet, it leaves you the opportunity to kind of go back and essentially redevelop. But at the initial check, it may tell you, well, that's not one of the ones that we're currently looking through, and that's so you want to go back and kind of look for the things. So that way, the designers have a tool to basically give them feedback in terms of our standard practices as we're starting to move forward. So if we go through actually scroll down just a little bit more, Josh.
I think that's the bottom of what we have here.
Okay, because there should be a little bit more where we've got the attributes reassigned down below. So we do have several attributes, and actually it should show up when we go through the video that are tied specifically to back to us. So basically, the material database that we're using is an attribute. The generic material type, so steel versus aluminum, that's an attribute as well. So why don't we go over to the video and we can kind of walk through from there, because it should show up as we go through. So we have a generic part in SolidWorks. It has a material associated with it, in this case, which is 6061 aluminum. The K-PAC for 6061 aluminum is set up the same way. In this case, we don't have any non-compliant materials in this, or non-compliant finishes in this particular K-PAC. As he scrolls down, which is going to happen in the video just momentarily, you can see that we have extra attributes that we're using there, and this allows us to use the dynamic approach to basically filling in this assessment. These attributes are all put in as part of the drawing properties, so these are all the drawing properties that we're currently looking through. There are others that we're using as well. So if you go through the material, you'll notice that in the next field, or 2 fields over, that there's a search piece that goes with that. The finish is simply a text field that we compare against, and we also have our drawing state, which in this case is a concept state, and there's certain things that need to be there in the concept state. So what we can do now is, if we create a new assessment, now we have in this case, we have just a single K-PAC that we're assessing against, but that's not the one we want to assess against. We want to do the ones that are there for the concept state, so that we go to the active developer here, we create an assessment, which in this case is for the Cool K-PAC demo. When we recreate the assessment, now what happens is it pulls material in. And in this case, we have a material that matches, and we have a finish that matches. And that's done essentially by the active client as it starts to pull that in for that assessment. Again, this is that particular K-PAC. In this case, it's number 50. If you go back to to where we're pulling this through, these are the attributes that we're looking at. We're looking at the drawing state, which in this case is concept. And then we're looking for any of the things that it should be pulling up at the concept state. So it's the material category, a material type, and so on. What this also will allow us to do, because we are in a conceptual phase, usually when this thing goes on, well, maybe aluminum's not the right material. What we can do is, if we go back to the part, change the material. So now we're going to go to steel, and we'll pick the 836 that Josh had up before. We're going, what he is showing here is we're going actually into the material tree, and this is the piece that we actually go through and sort against, so that we can actually have the attributes go to specific parts within the tree, so that you're not going through the entire database all the time. It narrows you down to steel, then it narrows you down to 836. If we start out again with the assessment we had in there before at K-PAC 60 or K-PAC 50, if we refresh, now what you'll notice is that it immediately takes our path back through the steel, to the steel, and that's giving us an error, because in this particular case where we have an aluminum finish called out for a steel part, and it says maybe you want to go back and look at that. And that's it.
Right on. Well, thank you very much, Jim. If we have any questions, we're going to take some question and answer. We have about 15 minutes left in the session. So if anyone has any questions, feel free to put those questions in the chat and we'll answer some questions. So we'll give it a few minutes to talk, go through. So we have a question from Marcia Castellani out at Ford Motor Company, and she says, Mauro, how does the K-PAC differ from a finite element analysis for stress calculation?
A great question. We did run some comparisons with FEA versus our textbook calculation, and we found out for this case, the stress level was pretty close when you're comparing FEA and the simple calculation. So we decided in this first step to go with this quick calculation. It literally takes less than a second to calculate, whereas FEA, you have to prepare models, you have to run the analysis. It takes a longer time. So we wanted something really snappy to apply. I mean, we do not discard FEA moving forward. Perhaps it's another level that we can add to the K-PAC. But for now, we found out actually the hand calculation is acceptable for what we want to do.
All right. It doesn't look like we have any other questions, so I think I'm going to go back to sharing my screen. We'll go to our PowerPoint so that we can facilitate the voting. Like I said before, you're going to vote. Oh, I did just have one question come in late. So can any of the contestants describe the specific value achieved with their K-PAC? So why don't we go in order? I guess, Mauro, you can go first, then we'll go to Darryl, and then we'll go to Jim. So can any of the contestants describe the specific value achieved with their K-PAC?
The value for the K-PAC I see is to avoid or minimize the number of redesigns. I mean, we have a number of designs that have failed endurance test. So if the K-PAC is applied, we see that the most of them that we saw in the past are not going to present a failure. So failures represent retooling, delays in the project. So the main value, once we apply it, every project will be evaluated against it, and we are not going to see the need of redesigning that interface.
Thank you, Mauro. I guess, Darryl, can you walk through and describe the specific value achieved with your K-PAC?
So there are a couple of things. First, it would allow us to track the proliferation of non-DFM items that we were using. There was an explosion of the number of the manufacturer was complaining about with the number of different hole sizes that we had. The second thing is that we use this information directly in our hole tool. And so now when you select a plug, it actually selects and places the corresponding plug that's supposed to go into the hole there, and now it's a one-to-one correlation. There's no mix-up. You're getting the right part number, and it's streamlined that process quite a bit. And so now person A can put the hole in their panel. Person B pulls that panel in his background. It sees information. It knows which plug, and then it adds the correct plug to their assembly. So it eliminated all of that confusion that we were going through.
Gotcha. And then Jim, can you walk us through and describe the specific value achieved with your K-PAC?
So for us, this K-PAC is part of a checklist for drawing completion and drawing release, so that as we're completing a design, there are specific steps that you need to go through to make sure that all of the things that are necessary for the model to be released are in place. By doing certain things at different drawing states, what it allows us to do is make sure that some of the basic stuff gets handled very early, and then some of the more detailed stuff gets handled towards the end, so that by the time you get to the end of that process and you're actually releasing the drawing, you're not spending as much time fixing models, which was for us, kind of an ongoing process where you went to do a release and there were items that were missing, essentially things that were skipped by the designer as they were going through the process. So this allows us to do kind of interim steps, catch the early stuff early, and then anything that's part of an early process piece. So that the two we showed there were concept and in work. There's actually a third one that's prototype, which is just before the release, like final release, that things that needed to get checked early would get checked at the concept state. When you got to the in-work state, it would check anything that was necessary for an in-work, plus all the stuff that had already been checked for concept, so that if there was anything to change, like the material. And then when you get to prototype, it checks all of the in-work and the concept pieces, plus all of the last-minute things that you need to do, which are mainly manual checks before the drawing actually gets released. So it does help to streamline that whole process, and it's a tool that they can use within the CAD program so that they're not constantly going back and forth between, the release process and the CAD system itself.
Right on. All right, well, I think it's time. We've got about 8 minutes left. I think it's time to vote. So we're going to make the poll live. Again, if you open up your chat panel on the right-hand side, you'll go to the little bar chart icon. We're going to make that poll live, and you can vote there. So the poll should be coming up here shortly. I think there it is. So go ahead and click on that bar chart icon next to the chat, and it'll give you a poll. I'm going to share my screen, and we will walk through who the previous champions that we have are, and then we will get to the results. All right, so we're voting right now. I think once you vote, you can then start to see the results in the poll. We will go live to the results in a moment. Some of the champions that we've had in the past, we've had Gary Svidrin from Navistar was our inaugural champion in 2017. Matt Barron from Borg Warner then won the cup in 2018. Nick Cassidy last year won the Cool K-PAC competition. I think we're going to give it about 30 more seconds. We're going to pull the final results up here and see who the champion is for 2020. So we got 75 votes coming in. We'll leave it for just a few more seconds. It looks like Mr. Yarbrough is going to be our champion for 2020. So we have 92 people in the session. So we're up to 79 votes here. All right. Well, thank you guys very much for participating. It looks like Darryl, congratulations. You've won
Thank you.
the competition for 2020.
Well done, Darryl.
Thank you.
Good job.
Congrats. So we'll get the trophy over to you, Darryl. We don't necessarily get to hand it to you right now, obviously, because we're virtual, but we will get that over to you. Your name will get engraved on the plaque as well. We certainly appreciate everyone entering the competition. This is, like I said, it's one of our favorite things in the conference. We get to see the different ways that people use the software and hear more experiences from the customer base. So we appreciate it very much. I think our next session is starting at 11:35, and that's where Mr. Moffa is going to talk about what's new with Oros IQ. So thank you guys again. Congratulations, Darryl, and we'll talk to you in a few minutes.
Okay. Thank you.